Everyone, my name is Dr. Tio Lawal from the Department of Physics, University of Unilorin, Nigeria. I'm here to demonstrate experiment 15 titled Determination of Refractive Index of Glass and that of unknown liquid using traveling microscope. I'm sure you must have seen this before. This is called the vernier traveling microscope. So, looking at the procedure, the apparatus given, you have a vernier traveling microscope, you have a beaker, and you have a pin attached to the beaker. Then you have a liquid. This is the liquid. The unknown liquid here is water. Then you have chalk. Look at the chalk, okay, given to you. So the first thing to do is that you have to take a piece of paper, then just mark a point, ink. Don't let it be too much. Something that cannot be visible to the eye. Okay, that's the essence of the vernier microscope. So what you do now is you place this in the microscope. Then when you look at the vernier, you discover that the vernier microscope has a cross wire. Yeah. So it has a cross wire. Now you are going to use the cross wire. You use the cross wire to bisect the objects that you marked as ink. Okay. While viewed through the microscope, adjust this up and down. What I'm sure you are going to see a magnified image of the ink that you put on the paper. So looking at this, you place this up and down. Okay, then by looking at this now, at this point, just check this. You are going to see a magnified image of the ink that you have marked earlier. Then, what next? When you look at the manual says when you focus focus on an ink mark on a white sheet of paper, place under the microscope. Note this reading as your reading H1. How will you do that? Your reading is going to be here. This is called the vernier traveling microscope. But the vernier is just like the vernier caliper that you all know. It has the main scale. This is the main scale reading, and this is the vernier scale reading. Don't forget to get your main reading. Whatever you have as your main scale, you add it to your vernier scale, and your main scale is before the 0 of the vernier scale. Okay, I'm sure. Don't forget how to make use of the vernier scale. So this is a vernier scale. This is a traveling vernier microscope. Okay, so this is the main scale, and this is the main scale, and this is the vernier scale. So don't forget, get your main scale, get your vernier scale, then add it together. That will be your H1. In addition to the apparatus needed is a glass block. I've told you it's going to be provided. If you don't have it, ask the technologists. Okay? So the manual says this is after obtaining your H1, then place the glass block on the paper marked ink. Then by the time you view through your traveling microscope, you discover that the magnified image you had earlier will now be blurred. So what you need to do is just move this up to get a magnified image. Yes, this is magnified image now. Okay, just try to adjust this so that the what I'm trying to do is so that the cross wire focus on the center. So though it is not focused, so I'm sure, yeah, this is a bit magnified. Yeah, this is the magnified image. Yes, that is the introduction of the prism. That's the block prism. Then whatever reading you have here, that is, you come here, get your main scale, get your vernier scale, record this as H2. Okay? Now, also, I told you the other time that I'm going to provide it with a chalk. Now, sprinkle the chalk on the glass block. Okay? And look at this. Now, this time around, you are not looking for the paper ink again. Okay? What you are looking for now is you are looking for the chalk powder. If you don't want to use the chalk powder, for the females among you that have powder, you can sprinkle the powder on this, but I'm sure you are going to be provided with chalk powder. So raise this up again. What you are going to see under the microscope is going to be as if you are looking at the cloud. That is what you are going to see here. As if you are looking at cloud formation. Okay, if you have ever traveled via aeroplane before and you now peep through the window, okay, all those clouds, okay, those are the pattern of the cloud formation you are going to see. So that is what you have when you sprinkle chalk powder on the block prism. So note the reading on this side as well, and that will be labeled H3. So if this is done, take away the chalk powder according to the manual, change the surface of the block prism, okay, check the then turn, initially use this side, then change it to this side and perform the experiment again. Repeat the above procedure. That is, take your measurements, then put the chalk powder and see what you are going to have. The difference between H3 and H1 is the real thickness of the block, and H3 and H2 is the apparent thickness of the block. Then calculate the refractive index from air to glass. You have mu A to glass of the material, and you have the expression. So that happens to be the first aspect of that's the procedure needed for the first experiment. So the next one is that let's look at the second one. This one, determination of refractive index of unknown liquid using apparent depth. Now, here you are going to repeat the procedure that we had in 15.2, but this time around you using an unknown liquid. So what you need to do is, this is when you check inside the beaker given to you, you have a pen. Okay, it's already it's there inside the beaker already. That's the pen. So focus on the pen. Let's see if you can see the pen under the microscope, and let's see. Okay, I'm sure I'm focusing on it. Yes. Okay. At this point, you can see the way I'm moving it. So this is the pen. Look at the pen. Yeah, that's the pen. I'm sure you can see the pen. So I'll focus on the pen, and so you record this. Focus on the pen at the bottom of an empty beaker and obtain the vernier reading. So good. So after I focus on the pen, take your vernier reading and label it as H1. I've told you, this is the main scale, this is the vernier scale. Add whatever you have on the main scale to that of the vernier scale reading. Okay? Then you record that as H1. Then the procedure 2, you are to fill the beaker with an unknown liquid and focus on the pen to obtain H2. So you have to fill the beaker with an unknown liquid. I've told you, the unknown liquid we are using now is water. So this is water. Just fill it. It's not actually specified. So just fill it at a depth. Okay. Then place it under the microscope. Adjust till you have a magnified image. Okay, you can see that when I move it down, I cannot see anything. So I move it up, and try to just see if you be able to see something. If you're able to see the magnified image, move it up. Just close one of your eyes. Okay, I'm moving it down again. Okay, yes, I can see the image. Don't forget, we are looking for the pen, but we've added water. Okay, and yes, I'm sure, yes, this is it. So this is the pen. Yeah, this is the pen at this point. Now, note your reading and record this reading as H2. Don't forget, initially there was no water. That one was noted as H1. When water was added, this is now H2. Now, the next thing is you have to sprinkle chalk. Sprinkle chalk, place it under the microscope. Then you are not looking for the pen this time around. You are looking for the sprinkled chalk. Yes, in fact, this is very clear. You see that the chalk, some of those chalk particles are trying to dissolve inside the water. But at this point, this is a clear magnified image of the chalk particle. Note this reading. Record this reading as H3. Where are you going to do that? This is your main scale reading. This is your vernier scale reading. Your main scale reading, add it to whatever you have on the vernier scale. I've told you, the reading using this is the same thing as the vernier scale that has both the main scale and the vernier scale. So transfer that knowledge to this. Now, vary the depth of this liquid 6 times and plot a graph of apparent depth H3 minus H2 against the real depth H3 minus H1. What we mean by that is, look at this, it is calibrated. In an attempt to, because you want to vary the quantity of water that you want to add to the beaker. Mind you, the first one that we did, that we sprinkled chalk inside the beaker, please dispose this. Make sure this is poured away. I told you earlier that the first one that we did, don't forget that you have to pour it away and get another fresh water without chalk particle. Although you still have to introduce chalk particle at the end of for the subsequent readings that you want to, at least you have to vary the depth. Okay, for another maybe 5 or 6. What do you mean by 5 or 6? That look at this one. Let's say this one is at 20 ml. Okay, then add the unknown liquid to, let's say, 40. Okay, this is 40. Place it under the microscope. Okay, get your measurements. Get your H1, H2, H3. Is that taken? That will be at 40. Sprinkle the chalk on it. I'm sure you're going to get all of those ones. Pour it away. Rinse the beaker. Then get another depth to 60. That's how to vary the depth. After that is done, sprinkle chalk in it again. Get your H1, H2, H3. Okay. If that is done, pour the water away. Okay. Then this is for depth at 60. Then go for that of 80. Sprinkle chalk. Measure, take your measurement, place it under the microscope, get your measurements. Then that is how to get a variable. You don't actually, the depth is not actually needed when you want to plot the graph. If you look at what we have here, what is needed here is H3 minus H2. That's your apparent depth. Then your real depth is H3 minus H1. Then plot a graph, and from the graph you are to obtain your refractive index from water, from glass to water. Okay, so this is the procedure for the experiment 15. Thank you and best of luck.